So last time I was saying that I had those 3 servos that I was showing. It said one of them is fast and one of them is not as fast and one of them is a piece of crap. And I said I would probably put the fast new one on my robot and try that out. So I did indeed do that. And I'm still confused here, so bear with me. So I'm going to say switch camera. Okay. And then view, make a big view. Okay, so there's the pretty much like it looked 2 meetings ago, but it's got the new servo on there. So if I plug this in, and this time I put a longer cable on so I don't have to get on the floor this time. So we'll see if it works. Yes, it does. So see it just like it did before, it turns like that. But this one, when I turn it, it turn it just a little bit, it moves just a little bit. If I turn it harder, it'll move to the point and then slams to a stop and then holds it. So that seems to be working. And then as far as the speed of it, let me get here so I don't break anything. Now I can turn like this.
Wow.
So it, let's see, how do I get, okay, there it is. Just a note, if you mute your microphone, then the screen will stop switching when you talk. So, so anyway, that's what it's doing. And that's the newer, what is that? ASMC-04A servo. And that's what it does. So that's all I got to show on that. Is any questions on that? Well, the other thing was, while I had the servo out, I decided to put a single connecting rod from the left side to the right side. And I kind of like the way the steering works at that point, but then now I would have to redo all the mechanical stuff to get to put a short connecting rod from the servo to one side and then leave the big one on. So I just went back to this one and put it back together like this. And that's all that's going to do for right now. So.
Is it off the ground or is it on the carpet, the wheels, that is?
No, it's laying on its back right now. So it's, it's laying on its back. And if they're on the carpet, they're just barely touching. So no, there isn't a problem, but I haven't tried it to see what it does. And I'm not going to do it right now because I've got everything piled up, so I can't get to it. So let's see, what am I doing? I want to switch back to here. And so I guess the other thing I did was I played with that, what Al was looking at last time or the time before, whenever that was. He was trying to get the his speeds, be able to adjust the speeds on his simulator. And I finally decided, I could fire it up on mine and try it. And that way I can poke through and check things out. So I went through last night and did that. It turns out I dug up all my old computers, and it turns out it's on my main computer. And so I got the thing fired up and was driving around, and I played with that. So the first thing I noticed was, yes, mine, if I drive straight up or straight left or straight right, whatever, I would get a different speed depending what direction I was going. I thought, well, that seems odd. It is totally directional dependent. So I played with that and finally decided that the message that I'm generating from Gazebo. So in Gazebo, I wrote a node that would pull up something out of Gazebo and produce this odometry message. And it turns out what it's doing is putting out the odometry message. It's putting out the velocities in the map frame format. So it, if you're driving up, it goes positive in one direction. If you go left, it get the other, like say, if you're going up, maybe it's the X value is giving you a velocity. If you go to the right, then your Y velocity is giving you a value. And that's, if you go look at if you're running Navsat fix, if you're running any of the GPS drivers, they will put out something called like GPS fix, and they'll also put out a GPS velocity. That velocity message there is a speed vector. So it'll say, here's your X velocity and your Y velocity. And if you want to use that, you have to interpret that. Well, this is basically doing the same thing. So I thought, well, when I looked at Matt's code for his GPS odom.py, he was just setting all those to 0. He wasn't setting them to 0. He just didn't set them to anything. So they came through as 0. So my guess is the original stage simulator is doing the same thing. It's just that nobody has noticed it yet. So I thought, well, if I set them to 0 and ran it, and that got rid of the variability. Now it always went the same speed, but it wouldn't. It was running at a slower speed, and I couldn't change it. So I thought, well, I'm gonna have to fix something. So then I went off and watched some movies or something, and came back later and looked at it harder and thought, well, what I need to do is convert that stuff coming out of Gazebo from the map frame into the robot frame. So as you turn, it always gives you an X, a velocity in the X direction. And I couldn't figure out the right way to do that. So I did it like I did on the GPS stuff. I just simply said, I treated it as a vector. So I took the length of the vector as my velocity. And I was trying to decide, do I need to do something with a rotation angle? And finally decided, no, I'm going to just ignore that. And I just simply took the length of that vector. So it's just a square root of x squared plus y squared, and stuck that into the the X velocity field. And that seems to have fixed the problem. So if we need to, I could fire up a demo here and show that running if people want to see that, or we could move on to whatever anybody else has to say. We can come back later. We can run the demo later if that's what people want to do.
Cool with that.
So I'll turn it over to somebody else for a while here.
Terry, you want to go?
Sure. As I said last week, I was working on my getting the PID to work outside of an interrupt. And I was able to successfully do that. And I've got the serial interface so that I can set the desired RPMs based on each individual motor, or I can set them both to be the same all in one command. I did hook up my USB. Let's see if I can share my screen. Where is that one? I know I've got the USB. Where is it? Come on. Why won't it let me do my USB? There. Okay. So if this is when it goes into the PID for a particular motor, it sets one of the pins high, and when it leaves the PID, it sets it low. And so here's motor 0, motor 1, and I can see that it's taking 2.9 milliseconds for that loop. And I have it only running every tenth of a second. And so here we can see that its period is, or its frequency is 10.5 kilohertz or 10.5 hertz. I thought that was kind of neat to see. This rest of this is just noise. So the next thing I'm going to work on from a hardware standpoint is adding 2 voltage dividers to be able to connect up and read what the current voltage is on 2 different drill batteries. So I'll know when I'm getting close to that. I'll be using the itsy bitsy's A to D on that, and have it generate a message if the voltage gets too low, so that it can say, hey, it's time to feed me. Then I started, I've got Ubuntu and ROS loaded, and now I'm going through the tutorials on building a package. But that's on another computer. But I imagine I could SFTP into it, but I'm not going to, because there's nothing really to show. But I want to get through those tutorials, practice with Turtle on Gazebo, and see what all the other tools are. That should be enough for next week. And then I will be gone the following week on this boat.
Seriously.
Yes.
Wow, there's 5 masts on that thing. That thing is, how long is that?
It's 440 feet long.
Oh my heavens.
210 passengers, I think. This will be my 3rd trip on it. First time my wife's going along. My son went with me the 2 other times.
That's awesome.
I think it's got like 54 sails.
Mm.
If you want to look it up, it's the Royal Clipper. So
Anything else?
that's a nice, that's pretty much where I'm at. Any questions? Okay.
Jeff and I, when we were together last week, we went into some of the code that's out on GitHub. I don't, again, for loops and PIDs or whatnot, you've probably got multiple examples, but
I saw that, and I determined that my problem was I had my constants. I needed to tune my PID was my biggest problem. And so I went ahead and tuned it, and it seems to be working pretty good.
cool. Well, I'm sharing, well, that's, where's the robot? Yeah, the robot's way over here in Gazebo. So while Jeff was thinking through that speed issue, I went ahead and moved on to trying to get move base flex, hyphenated here by MBF, to work. And the reason that I was focused on that is there's a couple of programs that we resurrected previously from Matt around creating a path and following a path. And there's other, I found while I was going through this, there's other examples as well. This example happens to come from one of the move base tutorials. But the bottom line for me is I've got move base flex running, and I'm able to issue a 2D nav goal in RViz. And so the next step that I was trying to do is to get one of these examples, either the tutorial example or Matt's previous example, to be able to run basically a mission. So this series of screens is complicated, but running Matt's
What's a mission?
a series of waypoints.
Okay.
So if I in the GitHub let's see, let me put that up. These are a series of 4 waypoints, X, Y, and Jeff knows this language better. It's an angle in
Either theta or heading. That's the heading you want to go.
Yeah. And so there's a program out there that will take those 4 points and create 30-ish, what is there, 31 points. So you see some of the points replicated here, and then it has calculated these other whatever dozen or so points per point. And that's, I guess, meant to give you a smooth position to follow. And then these two programs that are DIY, read this one, I think, is the one that reads that generated. Yeah, so this takes those generated points in and puts them in a pose and publishes that pose. It does it 13 times. Well, it does it repeatedly. I haven't quite figured out why he's doing it that way, but you'll see that here in a second. So at this point, I'm testing using those waypoints, using those that path planner, and seeing if I can get it to work. So I'm going to start one of the programs here in this window, start another program in this window. What you'll I'll ROS topic echo the path, and you'll see that that gets published. There's some other stuff on this screen as well, but let's just start with that. Now, when you see this screen change, you'll know that the path has been published. So it's thinking about it. And down here, it's trying to send it. And let's go back to RBIS and see if it's picked it up yet. Yeah, so RBIS has not picked it up yet. Whoa, what was all that? Yeah, that's interesting. So you can see a little bit of that circular. I was thinking it was going to go up this way. That's why I positioned the tractor down there. So yeah. So there's some fundamentals that are working, and there is some fundamentals that are not clear yet. And that is, what's exactly the behavior. And I think what I'm going to go do is recreate the path, pick some other waypoints, because I was thinking it was going to go straight up to that 22x and 2y. So I'm not quite sure why it jumped way over there. It looks like it's going to back up.
Well, that was going to be a question I'd had. Can you, in the path planner, tell it, I always want to go in this direction? Because if I'm thinking about my snow removal, I always want to be pushing the snow out one direction. So on my first path, I go all the way out, but I want to back up, then move over and go in the same direction, or have the front end going in the same direction.
So, I mean, I can comment, and Jeff's probably going to give you a better answer, but in the TEB planner parameters, there is a setting that basically weights going forward heavier. And I've got that set all the way to 1,000. So I'm not quite sure why this is backing up at the moment. So,
okay. I mean, I'm not anywhere near there yet. I just was questioning it.
Yeah, one of the parameters in this YAML file, weight kinematics forward drive default is 1, using 1,000 to restrict going backwards. Obviously, that's not getting the job done. So not quite sure why it decided to back up all that way.
Okay.
Now it's turned around. So the good news is I've got move base flex enabled to work. I've got Matt's path planner. I don't know what it's doing, but it's, you know, it's like generating a path and it's moving. That's good news. At the moment, the example that I was referencing over here, this one is not working yet. I've added some. Well, this was what I needed to put in to get RViz to take a 2D nav goal. So this particular program listens on move base simple goal, and it outputs this. So this was needed in order to get move base flex to work with a 2D nav goal. And the other one is, let me just close that. Can't see. Yeah, this is the other one that will take a series of points, and it's supposed to send this goal, and I'm getting goal sent waiting, but it never comes back. So I got to do some work on trying to get this one to work. So that's where I'm at. Trying to get planners to or trying to execute a mission and a series of waypoints.
To Terry's point, it hadn't occurred to me that you want to do what you say you're going to do, where you push snow forward and then you back up and then you push it again. You know, normally when they do these things, they'll just, you know, specify something and let it figure out how to turn around and go back to that point. Yeah, I see the advantage of doing that. Now it could be that you could go in and on the fly, you know, Matt or Al was just showing those parameters. He's got one that says, how do you weight it so it doesn't back up, or how do you weight it so it goes forward, or whatever. You might be able to change those on the fly. So, you know, you push your snow forward and then go out and say, okay, tell the thing I want to back up, and then give it the point back behind you and it'll back up. So you might be able to do that. So that's something that when you get that far, we can try that and see what that does. And specifically, it's the TEB planner is the one that allows you to back up, and most of the other ones do not allow that. And the thing is, you can throw all that stuff out completely and do your own path generation and path planning and all that kind of stuff. So you don't have to use, you know, what's being shown right at the moment. So there are other ways around that. But that
just tells me how much I have to reinvent the wheel.
Yeah, if you don't care where it goes, you know, just specify the point where, and let it drive back to that point, and then position itself, and then push snow again. You know, that would be the quickest way. But since now you can have snow in the way, that might be, you know, somewhat of an issue too. So that when you get that far, then people can go through and figure out, say, well, does this make sense or not make sense to do that? So that'll be interesting to see that.
Yep. I think I've been getting the cart before the horse.
No, you got to do it all.
I at least got to think about where the cart's going to go.
Yeah, there's I don't know, 30 things you have to be successful at to get all this to work. So anyway, a little bit of progress still. I was not expecting that result on the RViz demo, but we'll try to see what's going on with that.
So is it back to me now?
Sure.
Okay, to move my cart and my horse around, if you look at the chat, I pasted in there. If you take that, the code that says now and cut that out and paste that over the code in odom.pose, what was that called? Odom.py, I think it was called. And so it has these 3 lines in there, which is towards the bottom, and just paste over the top of that ones. And I think that's the quickest way to get this to work. There's some extraneous stuff in there that I need to clean that up, and I went through out of desperation and I put these float on it. So in the chat, it says, let's see. I was going to try to show a picture of this, but I'm well here. I can come over to this computer. I don't know if that's worked. So let me see if I can get my screen sharing to work now. Oh man. Screen share, select screen.
I see you have X and Y as float, and it's a result of converting result.twist.linear.x and the same thing Y.
Yeah, but out of desperation, I put the floats on there and realized if you want to do the A10(2) function, it's not Y divided by X, it's Y comma X. So once I fix that, I probably didn't need any of that float stuff on there. So let's see, I've got this now. You can see my screen.
We see you there you go.
Okay, so right here on this code, let's see, you should be able to see my cursor because I can see my cursor. So anyway, this chunk of code right here, originally it had the 3 lines saying odom child frame equals base footprint, and it said odom.pose.pose equals result.pose, and then the line that's commented out was the 3rd line that was there where it said odom.twist.twist equals result.twist. That's what it said originally, and that just copies over whatever Gazebo was handing me, and that turned out it was giving me a twist portion of the message as in I guess in the map frame. So as you say drive up, your X would increase, and if you drive say to the left, then your Y would increase. I didn't want that. So basically it just says X equals takes the result twist linear X. It's just pulling off the existing X value and saving it as X. It pulls off the Y value, saves that as Y. And then the next line that just says do the square root of X squared plus Y squared. That's just taking the length of that resulting vector and loads that into the just into the X velocity on the resulting message. And the next line, that is actually figured out the angle that might be a valid heading with respect to north, but I patched that out. I just simply stuck it into a field there so I could watch it on the screen while I was running. And the later side, I don't want that anyway, so I just patched it out. And then the last one just simply copies the original. Let's see, was that twist? This is so that was probably an original. That was originally going to be it was reading the rotational velocity and publishing that. So it just simply, I just modified it. So instead of taking the original XY, I converted the XY into a vector and took the length of that and put it into the X, and the Y field is going to be 0 and the Z field will be 0. And that seemed to fix my problems. So anyway, that's the explanation of what we were just talking about there. So if you, as I say, take the stuff out of the chat, which is going to be this whole, boy, there's a big lag here. So basically, the stuff in the chat is that. So paste that over the top of the what used to be the 3 lines, which originally had those 3 lines. So paste that whole thing over the top of those, and then that should fix the problem. And being Python, you don't have to do a cat can make. I realized that after I sat there for half an hour letting it compile everything. Then you can just go change that and run it, and that will work. So at this point, if you just cut that and paste it on top of yours and run it, that should fix your speed problem, I think. Until we come up with something new that needs to be fixed. So let me see if I can get this to do something here. And any questions before I go on? I'm going to start up a Gazebo and actually run it here to show you what it's doing.
No questions. Thank you for digging into that. I'm not sure I could have ever figured that out.
I didn't look good. So anyway, here's the I don't really need this, but it's kind of handy to, kind of cute to see it there. Oh, come on, give me the edge. No, it's down there. There's the vehicle. And, we could show that driving around or just ignore that. So we start up the next one, which is the all the navigation stuff. And I don't know what that means right now. I just know that if I run it, it works. So we'll do this. Comes up, says that's running. So if I fire up RViz and then I load. So someday I need to look up how to do this instead of having to go track it down every time. Home. Sim. Open. And I don't need this. So there's my vehicle sitting in the middle. And then over here, I've got, and I'll tell you what the are in a second. I'll just fire them up. So this little window here on the lower right, that's the command velocity, the modified command velocity coming out of the tab planner. So the tab planner says, I want you to go this fast and in this with this steering angle. And then the other window, the big window here, this is the odometry coming back from Gazebo. And the top one, the position, which is just your XY, XYZ position in the world, and then the orientation is a quaternion telling what direction you're pointing. And that I left that all intact. I don't know if I should have or not, but then down here under the twist portion under linear, originally I just copied this, so I had copied all 6 fields from Gazebo and dropped them in here, and that's where I was give me the velocities in the map frame. So I attempted to convert this to the velocity in the robot frame. And so you can see here, I'm filling in the X field. So that should be the velocity as we're driving forward, whatever direction we're pointing, that should give us the velocity. And then down here, the Z, this is the recovered rotational velocity from the vehicle. So basically all this is telling us where the vehicle actually is. And the one on the right is the odom, this is the command velocity message. This is the tab planner saying where I want you to go. So now we'll come over here and say, let's see, how does this work? I'll drive to a corner here. I think it's set to the default 0.4 right now. So I say I want to drive up there and I want to be pointed in that direction when I get there. So we fire that up. And let's see, it'd be handy if we could see it. Okay. And when it's backing up, I think it's set to 0.2 meters per second is the fastest it can back up. Once we get to the corner, it'll be a little easier to see what's going on here. So you can see as it's driving around, it's planning and showing you the thing here. Now down here, you see the speed goes up there. It's up to 0.4 as it's moving down in the, that's requested, and coming back is 0.37. So it thinks we're actually going at 0.37 meters per second. As I say, well, now I drive down here, we'll have a nice straight line. So let me do that. So we'll come here. And I have to stay within this grid because I've got on my map, it's got a big circle around here. In fact, here, I can show you that. If I say local cost map. So you can see on the edge here, this here is the edge of the of this big, it's got like a big fence around it. I don't remember where that came from. I just copied somebody's stuff and that's what it had. So I'll leave that turned on as we drive around so you can see, because you'll see it show up down here too. So if I say, give it a goal, come down to this corner, point it this way. Now, when I release this, you'll see it'll draw a path down to that point and it'll start driving forward. And then on the right, you'll see the, again, you'll see the command velocity saying, I want you to drive forward at 0.4 meters per second. And then the steering angle will show up in the Z value. I'll just go ahead and start this so we can talk about it. So I do that. And then see the command velocity says drive forward at 0.4 meters per second. And the Z down here is the steering angle. And the recovered data is around 0.4 meters per second. And the Z value should be the rotational velocity as it drives around. So here you can see the edge of that circle, the big fence that's around there. And as far as I know, no matter what direction I go here, this does seem to be working. And before we're done, I'll drive it a diagonal across and show that it's doing the same thing. So I'll do this again.
You mentioned earlier about the maximum velocity. Did you get that resolved, or is it still an open issue?
I found out I can run it up to 1.5 meters per second, and then it doesn't seem to want to go any faster than that. I'm not sure why that is. So I haven't looked at that yet. So we'll have that come around there. So while it's doing that, then I'll come back and say, I'll start up the configuration, what do you call it? Dynamic reconfigure. I notice on mine, if I just start RQT, it remembers where I was last time. So it should put us right back to where we want to be here. So I can minimize that, wait for it to come up. And I don't really have a lot of room to drive around here, so I'll put it up to 1 meter per second, and then come back here. Let's see, get this out of the way. And so I'm going to say drive straight up to here, and then we'll go watch the numbers again. Actually, let's move it over so you can see it. Now it says we're moving 0.97 meters per second straight ahead, and you can see the vehicle is moving faster. And we'll do that once more, just since I wasn't paying attention to what I was doing here. Okay, so I'm going to give it a goal over here on the right, and you can watch the linear velocity over here should say close to 1 meter per second, and then the recovered. The Gazebo is saying here's how fast we're really going, and it should be close to 1 meter per second. So we'll run that, and you can watch it here. Let me zoom in so you can see what's going on here. So I'm going to drive to this point here, so we'll do that. Go to here, and I'll say click, click. So you can see it's saying go forward at 0.97 meters per second, and the recovered thing says it's going around 0.97 meters per second. Well, that doesn't look right. What's it doing? What's it doing over there?
It shows a different way to get in that direction.
I don't know why I did that. That's just another one of those things. This stuff gets kind of mysterious at times. Maybe it's because I was too high or too low or something, but let's try that again. This, okay, zoom in on that. So we'll do the same thing again and watch. You can either watch the numbers or watch the vehicle driving around, but see, it looks like it wants to play the game. That's the way it usually does it right there. And by tweaking the numbers, you can get it so it doesn't have to back up like that. It should be able to, it should be smart enough to come in there and actually pick the right angle and then come there and stop. So I'll do the again over here. But see, the point is I changed by dynamic reconfigure. I said, change the speed from 0.4 to 1, and it seems to be doing that. So this time then I'll speed it up to something faster. I'll speed it up to 2, and I don't have a lot of room to drive around here, so it's hard to see what's going on, because as soon as it starts driving, it's going to move fast enough. It's going to be right at the end, so you won't be able to see what's going on anyway. So I'll move this down here. We're going to drive up to this point. So I go in and reconfigure again and change that to 2.0. No, don't change it to 20. That would be really stupid. And then come back.
Don't do anything too stupid.
Yeah, don't do anything too stupid. I found a video. I was going to send it to you and Alan, but I didn't get around to it. Now, before we're done here, I might remember what it was. So anyway, I changed that to 2 meters per second. Let's get everything set up. So I'm going to say go up here to this goal. And number 1, you'll notice the thing moves awful fast. Now, if you watch on the right there, the linear requested linear speed will say, it'll say like 1.5, I think it's what it's going to do. So it's around 1.5, and see it's moving pretty fast. but it does indeed work. So I told it to go 2, but it picked 1.5. So I don't know if that's something I put in the code to limit that, or if there's something else going on here. But in general, that, so it seems to be working, and that's an issue about how fast you can go. And if I were to say 1.5, and clear this, and again, do this and do this, and come here and say, go here. So if you watch the numbers this time, see, it's a little shy of 1.5. So as I say, I don't know if I've got something limiting that in the code, or it's just the way my parameters are set up or whatever. So anyway, that's just the way it goes. I just noticed here, my little icon of me talking, I've been trying to move that around so it's not on top of things. And it's a good thing it wasn't on top of I kept saying, here, watch these numbers. It's a good thing the picture wasn't on top of those. As I look back at the screen, the other thing I'll point out is you can see the covariance on both the pose and the twist is all zeros, because either of those didn't get copied across, or I probably could have just said copy the covariance field over, at least for the top one here for the position. They would have been the right numbers showing up. That's over here. Where's my cursor? So that's his block of numbers right here. And I could have copied those and got whatever Gazebo thought it was. And the ones down here, I don't know, since I monkeyed with it and changed it from the original format to something else, I don't know if the covariance would be valid anyway. So I haven't really thought about that. So that might be another issue to think about someday. Oh, I said I was going to drive it at an angle here just to show that it's really doing something. So let me go here and say, go there and come down. I think it's this one. We're going to tell it to turn around there. So if you watch all the numbers, this is running. So once it gets straightened out here, it's driving at about almost 1.5 meters per second. And it seems to be, so regardless of what direction I'm running, it does seem to give me the velocity in the forward direction. So that's what it needs to do. And that seems to be working. Which goes back to the fact, I'm guessing the stage simulator doesn't work right either.
So Jeff, that black line is marked as I cannot cross this line.
It's this wall in here. See, it's just got a fence that somebody created to put around there. So let's see, how does it know that? So when you start up, you create a map of your world. And so if you had a laser scanner, you could drive around and make a map of that, and it puts that into your map. So when you start the thing up, it loads it in. So if I come over here, can I get it from the map?
Is it possible to do that laser scan to get the basics and then add in others? For example, the edge of the driveway, the laser scan won't know that.
Yes. Yeah, it's basically just a graphics file. So you can just pull it up with a graphics editor and draw lines in there, and that keeps it happy.
Okay.
So I just turned on map, but I don't see, it should make the whole background white, and then you should see this all the way around here, but it didn't work for some reasons. I don't know. Either I'm displaying the wrong map, or what else could be wrong here. Map, color scheme. But anyway, you should be able to see that when Al runs his stuff, you can see that his has, he's got his map, and then you can see his house, and you can see all the stuff in the background. And some of that, I think in fact, he went through and said, he took the Google image, an image from Google Maps, and put it in there and scaled it, and just took a graphics editor and drew in some stuff, drew lines around his house to do it. So if you get that far, he knows how to do that. And I'm not sure I could tell you right off the top of my head how to do that. But yes, that is true.
That's down the road. It's just something that I was questioning whether ROS could do that or not.
Well, again, I think it's interesting, and it helps you get your head around what are you doing and how does all this fit together if you just do it in simulation. So whenever you want to do a map, let me know. We can walk through that.
Okay.
I have some instructions out there too, but they might be a little bit.
I think I'm a few weeks away from that.
When you're sitting on that sailboat and drinking that pina colada, maybe you can fire up your laptop and work on that.
As one last thing I'll do here, since we got the gazebo screen up, see, you don't even have to have the gazebo screen displayed. That's just showing you if you want to see what's going on, you can see it. So on the right hand is the gazebo screen, and on the left hand is the RViz screen. So I'll say pick a goal over here. We'll say again, do this, and you can actually watch it drive around over here on the in the gazebo world. It'll come down there and then it should turn around. And with any luck, I won't hit the wall, and I'm not close enough to it to hit it. So, but you can see the, let's see, how do you do like this?
Out of curiosity, how powerful is the machine that you're running all that on?
It's a i7 laptop, and I don't know, you know, I just what I'm running on. So I don't know. I was running yesterday, and things got bogged down so much I had to reboot the computer because then I couldn't get my browser to work. I couldn't get anything to work. So I don't know what took up all the space, because I looked at my what do you call it, the properties, the resources or whatever, and it didn't show that my memory is full. It didn't show that the processor is loaded down, but nothing was working anymore. So I had to reboot the computer, and that seemed to fix all my problems. So that's the end of my demo. And as I say, just cut and paste that code and that should fix your problem.
Well,
I still haven't verified if I can get it to run faster. I don't know why it's doing that. So I'll go ahead and start shutting stuff down here. In fact, if I can say, let's see, now how do I do that? I got to go back to this screen.
Terry, can you just comment a little bit about the oscilloscope that you've got? Is that a PC based?
Yes, it's a tool called USB, USBEESX. Hang on a second. Let me change my video to my other
print of it. It looked like it had 8 channels on it.
Yes. Let's see. Oh, I'm going to have to turn off my background. Hang on.
So you can do background if you go down to the video and do the little arrow.
Yeah, I know how to do it. I just had to get it.
Because we're not seeing your camera now. So
okay.
There we can see something.
This is the device. It's it's connected via USB. It's got these connectors. So I don't know if it'll focus on what they are, but it's basically channel 0 through 7, trigger, clock, and ground. And then I've got it connected to my itsy bitsy. I was also looking at the PWM and so forth just to make sure I was getting that right, but I'm not displaying it in that one. And you just run the software.
Looks very useful.
It was very, very useful when I was doing starting out using SPY, because you can set it up for it's got quick setup for I2C async. Right now I'm just using regular digital. You can set a trigger point so that I could say I could have a different whoops, I need to switch. Come on. Anyway, I could switch to have a second pin when I start a process, and then the first pin recording times and so forth. So that if I'm wanting to look at a particular SPY message, for example, if I've got a whole bunch going, but I want to have it triggered once a certain type of message, within my code, I can say, okay, I'm now going to start this message, raise this pin, and that'll trigger it to start watching. If you look down here, I don't know, am I still sharing?
Yes.
Okay. It's got capture once. I can set up here the sample rate and the buffer size, which then affects how big the sample is, but how many seconds it's going to record. And so I could have it, I can then say, okay, I want to see a certain amount of time, because I can you can adjust where that trigger will display. So even though the trigger may be halfway through, you can see what happens before the trigger. So it's very, I found it very powerful.
Cool.
You can have it, let's see.
Is that doing I2C right now?
No, it's doing just a quick setup digital.
Okay. Because the point is, if you set it to I2C, then it'll give you, it'll decode that and put hex values on the screen and show you what the message is going by. Or if you set it to async and hook it up to a serial port and say decode that, it'll give you the actual, it'll show you the actual text that is pulling out of that. So it's real handy. Beyond just a logic analyzer, it goes on and decodes all this stuff for you. So that could save you a lot of time.
Yeah, I was trying to find where that was at, and it's been a while since I've done that part of it. Oh, I remember. So this is saying that it's transmitting. I can tell it what colored cable input what signal is on what. So USB, SPI. Then I can say MOSI, MISO, and then what data format I want the output.
More to learn.
It's a neat little tool. I don't know that they sell this unit anymore because I've had it about 10 years. But I can't remember, did Alan have one?
I don't remember who started with one, but I have one. And
Okay,
Terry has
maybe it
one.
was,
I think
maybe it
Alan
was,
does have one.
maybe it was you that I saw had it, and it, when I was doing all that SPI communications with my previous one, it was very handy, particularly when I was trying to bit bang SPI.
I mean, Jeff, you have a regular oscilloscope, right?
Yeah, I've got a real oscilloscope too.
Always looked like too many buttons. I couldn't figure all that out.
I have a hard time figuring it out too, because the modern ones are even more complicated.
But I saw UART on there. You could literally hook up your GPS and see the NEMA sentences coming through that.
Yeah.
Yes, you could.
Wow.
Which, when I said I was thinking about decoding the battery communications, if that's I2C, I'd be able to see the messages going in both directions.
Cool.
It's a fun thing to think about. I'm not ready to do that at this point.
You have to Google to see what the current product list is for those guys.
They were just talking, I think on Homebrew Robotics, they're talking about these, and it turns out there's lots of different brands of these too. And they might have cheaper ones, they might have ones that work better. So I don't know, what the state of the art is on them, but they're talking about taking somebody's off the shelf product. I think they loaded different firmware in or something to do whatever they were trying to do. And I don't recall what they were trying to do at the time. It just alerted me to the fact, yes, there are other ones out there. In fact, I think somebody said you can do it on this $10 module, or you can go out and buy the one from Selig for $400, but basically they do the same thing. If I think about it, I'll try to find that. And because I think they said you can buy a $10 module that does what Terry's showing there. It may not have all the decode functions, but or maybe it does. I don't know. There was something on, they pointed something on Amazon and said, here, you can buy this for, it was very little money for whatever it was.
I've been very happy with it. Whenever I've had problems, they've always been operator error.
Yeah.
Any other questions?
I was just scrolling through their website. I don't see a price yet.
The model that I have is USB SX.
Yeah, I only saw one product and it's the QX. So,
And it could be they don't sell the SX anymore, so that might be why you don't see it. But I was thinking like at the time they're like 129 or 189 or something for it. But if you can get this one for $10 on Amazon that does the same thing, that would probably be a better investment. Even if it won't decode everything, it's great to be able to look at the timing, and you know, if you don't have an oscilloscope to look at this stuff.
yeah, I think that's out of my league.
Yeah, that's something different there. That must be a big box or something there.
What they show is that.
Google USB-EE space SX. And that, I mean, it takes you to the site, but to a different page that's specifically for this.
Hmm.
And at least it shows that you can buy it. To purchase that SX module.
Yeah, I back to their website. It has theirs. It has yours. Now, if I click buy, it takes me back to the 1495 one. No, don't do that. Anyway, thank you for going through that. It's very sophisticated.
I've been pleased with it.
I did a quick search on my messages trying to find that homebrew robotics one, and nothing turns up. So I'll have to dig into it later, but I'll try to remember to do that. And then if I find something, I'll post it to the list, the Slack, so everybody has an indication of it. And speaking of things that I was supposed to be doing, I didn't look at Al's spreadsheet. He put up that spreadsheet saying this is where all the values are, and I didn't get around to doing that. Instead, I played with this other thing and tried to fix the simulator. So I need to get back to that because mine, it's running my vehicle. It's not running Al's lawn tractor. And so when you switch from one to the other, that's when that spreadsheet comes in, and you have to figure out all the different places to track down the different parameters and different hard-coded values that should be fixed someday, but right now they haven't been.
Well, I'm very thankful you spent time on the pose angle, or that's awesome. Thank you.
You know, we can play with it a little harder and see if anything else shows up there. It could be that it's not right yet. And also, if we can figure out what's controlling that maximum speed, then we can, you know, if I trim a couple more lines out, I said there's some debug stuff in there of just that stuff I said you could paste in. And then once we get it figured out, then either you or I can go out to ROS Answers and say, oh, here's what the problem was, and this is how we fixed it, even though it's probably not the right way. So, you know, we'll play with it a little more, and we'll see if we get that figured out, and or debug it enough to make sure that it's doing what it's supposed to be doing.
Yeah, when I was trying to get my speed up, which I ultimately did, the penalty epsilon seemed to have a significant impact. I mean, I adjusted theta, acceleration theta, and acceleration limit to 2. I don't know what yours was at. I didn't see when you're going through RQT, but those are the 3 primary things that, again, notwithstanding the changes you just suggested, those are the 3 parameters that had the biggest impact on top speed.
Well, I didn't play with those at all. And I think just the fact that it was given it the wrong data is what the problem was. So, you know, if you put everything back to the, whatever the defaults were, and then
Go
you
from
then go from there and figure out why, if you put it a number bigger than what it wants, why is it limiting the speed? And again, it might come back to the fact that in that Ackerman, what they call Ackerman controller.py, I still think it might be clipping it in there and just saying, you know, don't go faster than this or whatever. But that's still to be tracked down, I guess. So that's just something else. So back to the point I just made, you know, playing with all those other parameters, we're only trying to get around the fact that it was getting incorrect data. So it, you know, rather than playing with those anymore, if you can, put them back to whatever the default was and go from there. But I did notice that mine seems to go fairly straight. And I was thinking yours was kind of wandering around a lot. Now it might be that if you put this change back in, that might correct that too, but that's just more things to look at as you go through there.
Cool. I won't answer the ROS answers. I think that's your prerogative because you'll get the karma points.
Oh, okay. I think I am registered for that, but I don't remember. I'll have to go down that path and see what's going on there. Any final comments to be recorded here? I'll take that as a no.